We are all concerned by earthquakes, and because they have such a destructive effect on our civilization, people are trying to understand them for a very long time. And they would like, maybe one day in the future, be able to predict or even prevent them. However, earthquakes are very complicated mechanisms and they are still not well understood. A traditional way of explaining earthquakes is that it is the stick-slip behavior between tectonic plates. So I can illustrate this here by having one tectonic plate, which is the book, the other one the table, and then the system, there is movement in the system, and due to the movement there is energy built up in the system, and at some point the interface cannot resist anymore and it will slide. A second observation that has been made is that if the rupture at the interface is fast, the earthquake has a higher potential of being destructive. So generally speaking, faster means more destructive earthquake. First looked at the stress. Today it's known that the rupture speed is coupled to the stress state at the interface. However, for experiments it's very hard to analyze or to access the information at the interface, and that's where we saw the opportunity of simulating this and analyzing this with new tools. And so during the last year we developed code where we are able to simulate interface rupture, and by doing so we saw the same general trends, but we also discovered this is not the whole story. So we saw that the dynamics are very important and that the energy flow close to the interface play an important role or is key to understanding. This is the rupture, so everything that is red is sliding, and we can see here it would stop, and this would be the stick-slip behavior, so sliding here, stopping here again, and then the whole thing would start again. By this new view, which is very exciting, we are maybe a little step closer to the understanding of earthquake and motivate new experiments to study the dynamic access of information at the interface.